conducting, the voltage is still going to be 0. Okay. Then what happens next? What happens next is basically at this point, both switches are off, right? So in this case, we would have D1 and D2 conducting, right? Switch, yeah. So like if this is the case, let's say like we would have, yeah, so we would have D1 and D2 conducting, right? And in this case, you would have output voltage of negative, right? And this would go on, okay? So just like wanted to show you that it's not necessarily the case that we would have these two switches on at the same time. And like when I'm talking about this one, this is like assuming that we still have some current going through this inductor, right? The inductor current is still like the inductor still has some energy. So like that's why we mentioned like we assume that we are in the steady state, right? If this decays to 0, then it can't turn D1 and D2 on, right? So this is assuming that the energy stored in the motor, like it's just gonna release itself and it's gonna absorb the same amount of energy. We're just assuming that we are analyzing this circuit in this case. And you can see that here we are operating in the first and fourth quadrant. That's why this is called class D, or 2-quadrant chopper. Okay. Now the last class chopper, you can also like analyze the output current up here. So like you can see that here current is actually decreasing and then increasing, decreasing, decreasing again, and then it starts increasing. Okay, so you can actually analyze this if you want, but for now let's just switch to class E. So class E chopper is actually a 4-quadrant chopper, so it can operate in all the 4 quadrants that we have. Let's call this one switch 1, this one I'm just gonna call it switch 2, this one switch 4, and this one switch 3. Okay, here we also have a diode D1, D4, D3, and D2. Okay, so I'm just gonna draw this one more time. VOIO. Okay, here both omega and tau are in the same direction. Here omega is still in the same direction, but tau is the opposite direction. Here both omega and tau are reverse direction, and here omega is in this direction, but tau is in this direction. Okay, so let's see how this works. And again, remember that if Vi is positive, it means that we are in the motoring mode. If Vi is negative, we are in the regenerative mode. Okay, so And I'm also gonna write this as well here. So in the first quadrant, second, third, and fourth, speed is positive. Let me just write omega. Omega is positive, torque is positive, and power is gonna be positive. In the second quadrant, omega is positive, tau is negative, so power is gonna be negative. Omega, it's gonna be negative, tau is gonna be negative, power is gonna be positive. Omega, it's gonna be negative, tau, it's gonna be positive, P, it's gonna be negative, right? So we could do exactly the same thing with voltage and current, right? The same thing, current, voltage, voltage, current, positive, negative, right? So you know that in these cases, we are going to be in the motoring mode, right? What's the difference? Sorry, this case. What's the difference between these two? It's the direction of the rotation of the motor. So here, like, it's assuming that counterclockwise direction is positive, it's rotating in the counterclockwise, and here, like, it's rotating in the clockwise. And in these two quadrants, we are gonna be in the generative mode, right? So that's why this is called forward motoring. This is called backward motoring. And this is called forward braking or regenerative braking. This is backward regenerative braking. Okay, so just like assume that, let's say, assume that like we have, let's assume that we have an elevator that you're just like pulling up or like pulling down. So if you're going in this direction, like, that means that the motor is running in the counterclockwise direction. If, let's say, like, you start the motor and it has a positive torque, and it means that it's going to be in the forward motoring section. So, but let's say that like you're getting close to the level that you want to get off, right? So it means that you're still like the motor is still rotating in this direction, but the torque, it's now going to change the direction because you want to slow down, right? You want to stop, right? So the torque is basically applying a force that stops the elevator. So that's going to be forward braking. So let's say like you want to get on the elevator and you press like level 3. At this point, the motor, it's going to be in the forward motoring, right? When it's getting close to level 3, the motor is going to stop, right? So the direction of the speed is still counterclockwise, but the torque, it's going to be in the opposite direction. So it's going to be forward braking, right? And in this case, the motor is going to be generating energy. The mechanical energy that's stored in the machine, it's going